Hi everyone, in this video we're going to discuss clinical UPS 3. So for the first questions given here, a px is a cubic function, a qx is a quadratic function. Which of the following is equivalent for this operation? First of all, we make this qx squared. So it will be a squared plus 2ab plus b squared when you want to expand it. So x squared will be equals to x squared and square x power 4, 2 times a times b negative 4x squared, then b squared positive 4. Then we minus this. Negative, negative become positive. So we have the first term negative 4x squared, negative x power 4. Second term cubic, power of 3. Third term power of 2, minus 8 plus 4, so minus 4. Then power of 1. Then constant, minus 11, minus 5, minus 15. So we have this option as an answer. Next, given this cubic polynomial, it can be written in division and quotient with remainder. Find the remainder. So when you divide by x minus 3 means x equals to 3. We put it into our polynomial. Then we can get it. What is your remainder? So here we have negative 26. Next, a polynomial is divided by this, state its quotient. So we finding our quotient using long division. We rearrange this polynomial in order, start from the highest power, continue to the power of 2, then power of 1, then constant. Then we divide with this divisor. Divisor is negative x plus 1. Rearrange it. So first of all, what you need is positive x squared, so that you can multiply with negative x. You get negative x cubed. Then expand for the following plus x squared to find its remainder. Remainder we minus. So here we have 0. Then 3 minus 1 we get 2. Again, we need a positive 2, so we need to multiply with negative 2 with x. We can get positive 2 with x squared. We multiply, expand, minus 2x. We find the balance, minus out, so negative negative become positive. We can get negative 4x plus x plus 8. Then minus 4, you need negative, so positive 4. Multiply with negative x, negative 4x. And then plus 4. Then remainder is 4. So the quotient will be x squared minus 2x plus 4. Then which of the following expression represent a proper? So proper fraction means the numerator power will be smaller than the denominator power. So here maximum power is 2. Denominator, when we expand this, is also 2. This is improper. And then this is linear, power of 1. When this expand, we get x power of 2. So this is proper. So proper means the power, maximum power at numerator must be smaller than denominator. So when you see option 3, this power maximum is 3. This is 2. So this is improper. And we look at this, when we expand, we get a quadratic. When x times x also, we can get a quadratic. So this is improper. Next, find the value of n, show that x minus 1 is a factor of the polynomial. When x minus 1 is a factor of the polynomial, means x is equals to 1. We substitute into the polynomial, it's supposed to get 0. So 2 times 1 cubed, 5 times 1 squared, 1 plus m, 0. We find out this m is negative 6. So we have maybe option 1 or 2. So you can see our polynomial now is 2x cubed plus 5x squared minus x. M is negative 6. When you want to find the remaining roots, means you want to find its factor. So to find its factor, you let it to be 0. You can press your calculator using cubic polynomial. So you can take your calculator, start from the mode, taking the equation, which is a. We take number 2 for polynomial. Then we degree of 3. So we find out all the factorize or all the roots from the calculator. So we have a is 2, b is 5, c is negative 1, then d is negative 6. So you put in equal, then you can find out what is your root. Your root x1 is 1, then x2 is negative 3 over 2, and then x3 will be negative 2. So since one of the x equals to 1 is already mentioned, therefore the remaining roots will be negative 3 over 2 and negative 2. So here we have our option. Next, given the fraction expressed in the partial fraction, they ask here what is the equivalent expression when comparing the numerator of the right hand side. Means we are going to get same to the denominator, we compare, we want to put it into one equation. So 3x plus 1, a will be multiplied with the factor it don't have, so you need to times one factor x and one factor x minus 1. For b, you can see in denominator already have x squared, so it's going to times x minus 1. So for c, it already have x minus 1, so it will going to times x squared. So therefore, this is the equivalent expression when it comparing the denominator. So here we have our option. Then the next question, they say, given that this factor form is equals to this expansion form, means this is one part of the step from partial fraction where it already gets same to the denominator. So we want to find the value of a, b, c. We need to let it 3 times. So let it x equals to the roots. It will be easier. You can see factor of 1, we can let it x equals to 1. Factor of x plus 2, we can let it the factor of negative 2. So this is repeated. So this is, we can let it to be x equals to negative 1 over 2. So when we substitute 1, it will become 27. So it will be eliminate this factor and this factor, so we can find in the c. So c is 3. So we might have option 1 and option 3. Then we continue. When we have x equals to negative 2, we substitute. So negative 2 is come from this factor. It will make it eliminate a. Also, from here we can substitute. We find b. Then for this, it will be eliminate. So we find out this one. So for the Left hand side we have negative 9, and then this b is substitute here is negative 2, negative 3 times high b. So b is negative 1. So they have similar negative 1. So to determine which is the final answer, we need to find out our a. So when x equals to negative 1 over 2, we substitute and see. Finding our a. So here we have our a will be 4 over 2, negative, negative simplify. So a will be positive 2. Therefore, we have this option. Then which one is not polynomial? So to become polynomial, x to be the base, power will be the whole number. So this is indices. This is not correct. This x is power of 1 over 2. This is also not polynomial. So therefore, we have option 1 and 2. If two of the zeros of the polynomial are 1 and negative 2, the other 0 will be, so zeros is come from roots. Roots can find from factor. So to factor this cubic, we can use calculator. So again, with the mode equation A, take out your polynomial 2, then you key in your degree of your polynomial is cubic, which is 3. Then put in your A is 2, enter with quadratic is negative 1, then negative 7, then 6. So they will count out all the roots here, negative 2, then 3 over 2, x1, x2, x3. Then you can know what is your another zeros. So our another zeros, so 1 and negative 2 already mentioned, another 0 will be 3 over 2. Then given cosecant is 1 over p, find cos square in terms of p. So cosecant is 1 over sine x is 1 over p, means sine x is p. Then cos square plus sine square will be equals to 1. So cos square will be 1 minus sine square. So sine is p, so it will be 1 minus p squared. Therefore, here we have our option. Then next, express this as a sum or difference of the trigonometry function. So actually, we can do it in the other way. You can see this one is sine A minus sine P. It will be faster. It will be negative 2 cos A plus B over 2. And then sine A minus B over 2. So 7x. And then this is negative 6x over 2 become negative 3x. So sine minus sine is positive 2. Then negative angle take out, it will be negative 2 cos 7x sine 3x. So therefore we will have this as an answer. Again, sine P minus sine Q, it will be 2 cos P plus Q over 2, then sine P minus Q over 2. So you can test one by one. If this one, it will be 2 cos 7x over 2. So look like it is much more difference. And then this one will be 2 cos 14 over 2. So 7x. Yes. Then sine 6x over 2. It will be 3x. So it's just missing of negative. This is not correct. Then for this one, 2 cos p plus q over 2, 7x over 2. So this is not correct. So given that shift tangent negative 1 is x, shift tangent 2 is y. So actually this one, we have to rewrite it. It's supposed to be tangent x equals to negative 1. Tangent y equals to 2. To find tangent x plus y, we use compound angle formula. Tangent x plus tangent y, and then 1 minus tangent x, tangent y, put in the formula. 1 minus negative 2, negative become positive. So here we have, this is our option. Then which expression is equivalent to this? Alright, so we need to simplify. Sine 2 theta, you can see our answer no longer in double angle. Sine 2 theta is 2 sine theta cos theta. Then some more sine square theta, so we can see we can simplify. We simplify first. 2 sine square theta, 2 can be simplified, sine can be cut out. So cos theta over sine theta, it is equal to cotangent theta. Then next, for which of these value x is not the solution? When the x is a solution, we can fulfill the equation. So tangent theta over 2 is equals to 1 over sec 3. So if in calculator 1 over sec 3, when we rationalize it, you will sec 3 over 3. So to test which one is not the solution, we can substitute one by one. You can press your calculator when tangent negative 150 divided by 2. It gives us negative 2, so this is not. So when you replace your negative 150 with 300, it will give you sec 3 over 3, so this is your solution. And you replace in your calculator your data as 60, so you press one by one to test. So this is sec 3 over 3 also. Another data is 420, so substitute there. It is also sec 3 over 3, so this is not the solution for this equation. Then solve the equation for negative pi to pi, so they want in terms of pi. First of all is our range, negative pi to pi. So you can see our equation already, symbol, basic, trigo, angle equals to value. So this equation is ready to solve. So for range, we adjust to the range of the data here, plus pi over 6. So 7 over 6 pi, 5 over 6 pi, negative. Then step number 2, quadrant. Cos positive will be quadrant 1 and quadrant 4. Then step number 3, basic angle, which is shift the cos to the value. So remember to put your calculator angle unit in radian so that you can get your basic angle in radian. So shift cos 1 over 2. It will give you basic angle as 1 over 3 pi. So here is 1 over 3 pi, here is 1 over 3 pi. Then number 4, we're going to rotate. So negative angle, we're going to rotate down as negative 5 over 6. So negative 5 over 6 pi, negative 5 over 6, it will be equivalent like negative 0.833 pi. So if you want to rotate to open from the opposite rotation as much as negative 1 over 3, the decimal is 1 over 3 is equals to 0.333. So we can open it negatively. So we can see our range as negative 0.833, and then our basic angle can go down negative 0.3. So this range, this negative angle is in the range. So our theta pi over 6 rotation is negative pi over 3 from the quadrant 4, and then quadrant 1 pi over 3. Then we want to go for quadrant 4. So if I want to go for quadrant 4, we need to take 2 pi and minus the basic angle 1 over 3, which is 5 over 3. So consider 5 over 3 pi in decimal is 1.67, and the maximum range 7 per 6 is 1.167. So this quadrant 4 rotation is up from the range because you can see our angle is above or more than our maximum value. So we have two answers here. Then we simplify the data. Negative 1 over 3 plus 1 over 6. Negative 1 over 3 minus 1 over 6. Negative 1 over 2 pi. Then this one, 1 over 3 minus 1 over 6. So we have pi over 6. So we have option 2. Continue. So if this expression can be expressed in compound angle, find the R and alpha. So first of all, you expand your compound angle here. Sine A minus B, it will be sine A cos B plus cos A sine B. Then you compare sine theta coefficient R cos alpha is 8, equation 1. Cos theta here, cos 2 theta here, coefficient is 6. So R sine alpha is 6. To get R, you use identity. So R squared cos squared plus sine squared, we get 1. So take out the R, so 8 squared plus 6 squared. So R will be square root of 100. We get 10. So here we have our option here. To find alpha, we will build out a tangent. So equation 2 over equation 1. So R sine alpha divide R cos alpha, 6 over 8. R can be eliminated. Tangent alpha 6 over 8. So alpha is a basic angle. Move your tangent to the right hand side. So shift tangent 6 over 8. it gives you 36.87. So here we have our option. Next, by using t equals to half tangent half angle, for angle is acute angle, express this one in terms of t, means that this is your t substitution. So when you're having t as a tangent half angle, we want to find sine theta plus cos theta equals to 1. So sine theta is expressed as 2t over t squared plus 1. Then cos theta in terms of t is 1 minus t squared, 1 plus t squared equals to 1. So what can we do is we get same to the denominator, 2t plus 2 times 1 minus t squared. This denominator, we multiply it to the right hand side, t squared plus 1. Then we rearrange this. So we simplify the negative, then we can get our option, which is this, option 4. Then find the maximum value for this inverse function. So normally for cos theta, its range maximum will be 1, minimum will be -1. But when it under 1 over 5 times 3 cos theta, when this triangle is inverse, means the maximum, the minimum also will be inverse. So for 1 over cos theta, the maximum value will become -1. The minimum value will become +1. So therefore, to find this maximum value for this cos theta, when it inverse, we will take the negative. So 5 minus 3 will be equals to 2. So here we have our option. And that's all for this discussion. Thank you for watching.